Good morning everyone. I am Renu Sharma, Assistant Professor Ajay Kumar Garg Engineering College. Today I am going to start with the next lecture for the subject, that is Data Communication Networks. Its code is KEC 063. So, the topic of today's lecture is error detection and correction codes. So, I will begin with the contents of this lecture, that is introduction, then types of error and block coding. So, first I will begin with what is why we have to study this error correction and detection. Whenever we want to transmit our information, we want to communicate, the information is in the form of digits, like it is in the form of 1 and 0. So, this is known as binary data, or you can say it is in the digital form or digits form, because the information that you want to transmit is in analog form, and to make it more immune to noise you have to use ADC, that is analog to digital converter. Before the transmission, before the channel, the ADC is being used to transmit the information in the form of digits, in the form of binary data 1 and 0. So, for whenever you are transmitting this kind of information, also in analog also it will be affected with noise. But in case of this binary data, if you are transmitting, let us say I will take an example, if I am transmitting 1 0 1 1, 4 bits of data I am transmitting, and I will receive this 0 0 1 1. So, at the receiver end you cannot find that whether the error has occurred or not, because I am receiving this information, this is at the transmitter side and this is at the receiver side. So, for that whatever information we have received at the receiver, we have to use the error detection and correction. First we have to find out that whether it is affected with noise or not, whether error has occurred or whether the bits have been changed, whatever we have received. Secondly, if the error has occurred, then you have to correct that particular error. And what kind of error will be there? Either the bit will change from 0 to 1 or it will change from 1 to 0. So, this is very simple in case of digital form, but when we are handling analog information, then to detect the information it is very difficult and it will be more affected with noise, analog signal, but in case of digital signal it is less affected to noise, and only it will either change from 1 to 0 or 0 to 1. So, in this this is how we have to in this manner how we have to find out the whether it is affected with error or not, and then we have to remove that error. So, we have to correct that particular error. So, this is the introduction. In this we will see types of error. So, once we have seen that how the error has occurred in digital information, like it will change from 1 to 0 or 0 to 1. So, there are two types of errors that may occur. First type of error is the single bit error, second type of error is the burst error. Burst error, or you can say more than one bit is affected with the noise. So, this is the diagram of the single bit error. What is single bit error? This name is self explanatory. Single bit, either one will change to 0 or 0 will change to 1. Let us say I have an information of 1 0 1 1. These are 5 bits of information I am transmitting, and I am receiving this as a at the receiver side. So, you can clearly see that this bit has an error. So, this is known as single bit error. So, this is also an example. You can see that there are this much information I have sent and this information I have received. This is at the transmitter side or the sender side, and this is at the receiver side. So, you can find out that 0 has been changed to 1. So, this is the simplest kind of error that will occur, that is one bit error or single bit error. Now, next we will see burst error. Now, burst error, this is an example of the burst error. So, there are two different types of burst error are there. Either the consecutive bits will change from 0 to 1. Let me take an example, let me explain with that. Let us say I have transmitted this information, this is at the transmitter side, and I have received information, like I have transmitted 0 0 1 1 and 0, and I have received information, that is this information I have received. So, you can clearly see that these 3 bits are changed, like first 2 bits are changed from 0 0 to 1 1, and this bit has changed from 1 to 0. So, you can say that 3 bits are changed. This is not a single bit error case where only 1 bit has changed, it has 3 bits have changed. More than 1 bit will change, is an example of the burst error. Secondly, this is the case for consecutive change, means the continuous 3 bits have changed. It is not like that first bit has changed, then after that third bit has changed. This is an example, this is a second type of example of the burst error case, where you can see that this is the transmitted data and this is the received data. So, this is the transmitted one, this is the received one, and in this case you can see that these 2 bits have changed, then these are same, then this is changed, these are same, this is same change. So, this means these are corrupted bits, and you can say that this is not the case for the consecutive bit error change. This is the case for alternate, you can say, or when at whatever place the information can going to affect the quality of the signal. So, this is an example, or you can find out the types of error. So, there are 2 types of error are there. First one is the single bit error, second one is the burst error. In case of burst error, there are 2 conditions are there. In first case, consecutive bits can change more than 1 bit. It can be possible that 2 consecutive bits will change from 1 1 to 0 0 0 1 to 1 1, whatever will be the combination. Second type of burst error is that not consecutive, it will going to change after some spacing. So, this is the both the cases burst error. Now, next we will see the diagram of encoder and decoder. So, for detecting the information, or how we are going to how the data will be generated at the encoder side and how it will be regenerated at the receiver side, it will be more clear from this diagram, that is the encoder and decoder. Now, encoder is a part of ADC, you can say. ADC is nothing, it is a analog to digital converter. There are 3 different steps for converting the analog signal from analog signal to digital, that is the sampling is the first step, second step is the quantization, third step is the encoding. Now, to encode the signal, we can take any number of bits, it is denoted by n is the encoder. You can take 2 bits, 2 bit encoder can be used. Now, what is the use of 2 bit encoder? 2 bit encoder means we have 4 options 0 0 0 1 1 0 1 1. So, this is a 2 bit encoder case. When you are considering n is equals to 3, then you can say that there are 8 different options are there, from 0 0 to 1 1, then it will be 0 0 0, it will be 0 0 1, then 0 1 0 and so on up to 1 1. So, there are 8 options we are having. If the dynamic range of the quantizer is quite large, means if the amplitude level of the signal will vary from, let us say, from -8 to 8. So, 2 bits is not enough, we have to consider 3 bits of encoder, or it is more good if you are taking 4 bits of encoder. So, V will be is equals to 4. So, this is the case for ADC, that is analog to digital converter. Now, why I am explaining this here, because in case of encoding, how the encoding will be done, it will be done by this diagram. You can understand that this is the encoder, and same at the receiver side, you have to convert the digital information back in the form of original form, that is in the analog form. So, you have to convert back into the analog form, from digital to encoder. So, at the receiver side you have to use DAC, and at the transmitter side you have to use the ADC. So, this is the main part of the communication. Whenever you are going to set up a link between the transmitter and receiver, then the original information has to be converted into the digital form, that is being done by ADC at the transmitter side, At the receiver side, you have to convert back the information from digital to analog using this DAC. So, this is an example at the receiver side. Now, we will concentrate on this diagram. What a diagram says, that this is the message signal. Now, what is message signal? Message signal, it can be, it is in the analog form, it can be in the form of analog, it can be in the form of text, it can be in the form of image, or a video will be there, means 2D signal, 1D signal or 3D signal, whatever signal you want to transmit, this is the original message signal. Then it is been given to the generator, where the generator will going to generate a message and the redundancy information. Now, this redundancy information is been appended or is added to the original message data, so that it will be transmitted over a longer distance, and it will be used for encryption purpose, means to increase the security, it will be going to be transmitted, or the redundant information will be added to this original message signal. Now, it will be transmitted over the unreliable transmission. Now, a new word occur, what is unreliable? Unreliable, basically there are two types of transmission are there. First one is the reliable transmission, second one is the unreliable transmission. Whenever you are going to rely, or you are you know that whenever is there is any problem in the connection will take place, then it can be resolved, or either it will be resolved automatically, or you know that where the problem is occur and you can resolve it. So, that is known as the reliable connection, you can rely on that particular transmission or the connection. But in case of this unreliable transmission, you cannot rely on the connection that you have set up between the transmitter and receiver. If any problem occur, then you have to just find out that where the problem has occurred, and it is time consuming basically. So, this is the main disadvantage of using the unreliable transmission. So, this is how the unreliable transmission will take place. You have set up a link between the sender and the receiver, this unreliable transmission, and it will be received at the receiver side. So, this is here you are going to receive the message plus the redundancy information that you have added at the generator, and then it is being applied to the checker. Now, at the receiver side, you have to check that whether the error has occurred or not, whether it is single bit error or whether it is burst error. In burst error also there are two options are available, that whether the consecutive bits have changed from 1 to 0, or whether there is a gap between the error that has occurred. So, this is the main function of this checker is there. Then it will be given to the message, then the original message will be generated. If it is correct, then you have to give it to the message, and if it is not correct, then you have to discard. So, this is the very simple form of error checking is there, error detection. There is no error correction option is available in this diagram, you can see, because if the error has occurred, then you have to resolve that particular error. You do not have to discard that particular information. So, this is the case for receiver side. So, this is encoder and decoder diagram. Let me explain you once again. This is at the sender side, this is at the receiver side. At the sender you have to use the encoder, at the receiver you have to use the decoder. At the sender you have to generate the particular message which will be in the form of analog, either it can be a 1D signal, means it will be in the form of text, it can be a 2D signal, means it will be an image, or it will be a 3D signal, it will be a then it will be a video. Then whatever information you want to transmit, it is in the analog form, then you have to give it to the generator, where the generator will going to append the redundancy information with the message signal, so that the proper correct detection of the error will take place at the receiver side. Then this information will be transmitted to the receiver through this unreliable transmission, means you cannot rely on the connection that you have set up between the transmitter and receiver. At the receiver side, the information is first received, which is in the original form, that is the message plus the redundancy. Then it will be given to the checker, where the checker will going to detect that whether the error has occurred or not. If it is correct, then it will be passed through the message, and if it is not correct, then it will be discarded. now we are in the coming slides we are going to see that how the information will be checked, because there are different codes are available where you are going to detect that whether the error has occurred or not, and there are different codes are available where you can correct that particular error which has occurred. So, this is the introduction of encoder and decoder. Now, the next we will see block coding. Block coding is also known as linear block code. It is also known as linear block code, or in the short form it is known as LBC, linear block coding. Now, in the block coding we divide our message into blocks, which means let us say I want to transmit 10 bits of information, then I can break that 10 bits of information into equal to 2 bits of information. So, this is how the block coding will work. In blocks you are going to divide your message. Let us say if it is 20 bits of information I want to transmit, then I will going to break that data into whatever combination it is possible, either 2 or 4 bits of information we can find out. We can break into blocks. Now, each of the k bits called as the data words. So, we add the r redundant bits to each block to make the length, that is n is equals to k plus r. So, let me explain you what this is saying. N is equals to k plus r. This is the formula, n is equals to k plus r, which means the total length of the data will be of n bits. K is the message bit or the block number of bits in a particular block. Let us say in one block 1 k bits are there, in next block another k bits are there. So, this is how the bits will be divided, the original message will be divided into number of bits, then it will be added with the redundancy bits. Now, these redundancy bits or the check bits you can say, it will be checked at the receiver side with a different combinations are available. I will explain in detail. Now, this combination will going to will be checked at the receiver side, and if there is any error, then we can say the original k bits will have an error. So, the actual data, that is k bits, will not be checked, only the redundant bits will be checked at the receiver side. So, this is the original length of the block code, that is n is equals to k plus r. Now, the resulting n bit blocks are known as code words. So, this n is equals to k plus r is known as the code word. This k is known as data word, and this r is known as redundant bits. So, now, so these three terms are very important if you are studying the coding part. This is very important if you want to study that r is the redundant bits, then n is the code word and k is the data word. So, this is the bits that you have seen over here. Then this is 2 to the power k data words. Each of the k bits are available over here, that this is k bits of information you can see, and number of data words that will be possible will be shown by this multiple, that is 2 to the power k number of data words will be possible in this combination in block coding. Now, next will be the n number of bits, that is each n is equivalent to k plus r. K plus r means data words plus the redundant bits. Now, next is also been is equals to k plus r, then this is also is equals to k plus r. So, this is the n bits, n number of bits of data are there. So, how many code words are available using this combination? That is will be equivalent to 2 to the power n code words. Each of the n bits will be there and only 2 to the power k of them are valid. So, basically what it says in block coding, whatever number of bits you want to transmit, firstly at the first step, at the very first step, it will be broken into or it will be divided into equal number of blocks. that is known as the k number of bits. Now, each block will be added with the redundant bits, that is denoted by small r. So, in the resulting code word or in the resulting block coding, this n will be is equals to k plus r, that is total number of code words. Now, in every bit only 2 to the power k of them are valid bits. So, this is the code word, this is about the block coding. Now, next is the error detection in the block coding. So, how this error will be detected in the block coding. So, the same diagram is there, but you can see it is divided into bits. So, this will be more easy to understand. This is at the sender side, this is at the receiver side. Encoder is used at the sender side and decoder is used at the receiver side. So, in this there are two terms are used. First one is the data word, that is possible number of data words which are possible is 2 to the power k, we have seen in the earlier slide, and total number of code words that are possible, that is denoted by 2 to the power n. Then this k bits will going to generate this data word, it will be applied to the generator and then the code word will be generated. This code word will consist of data word plus the redundancy bits. So, this will be k plus r, n is equals to k plus r, this will be the code word. Now, through this unreliable transmission, because we do not rely on the combination on the link that has been set up between the transmitter and receiver, this is the unreliable transmission, it will be applied to this receiver side and this is the code word that we are having. Now, this code word is which consists of the original data, that is data words plus the redundant bits, it is applied to the checker. Now, the checker, the r bits will be checked with a set of combination, this will be checked that whether the error has occurred or not. If the error is there, then it will be discarded that original message data bit, and if it is not having any error, then the data original data words will be extracted and it will be delivered to the original data word, that is k bits. So, this is being received at the receiver side. So, this is error detection and in block coding which is been used over here. Now, this is error correction. This diagram is showing that how the error will be corrected. This is at the sender side, the same diagram we are having and the same receiver we are having. You can see the encoder is somewhat same. It will going to generate the k bits of data, it will be applied to the generator side, then it will be given to the code word that is having the n number of bits. Then it is applied to the unreliable transmission, you cannot rely on this transmission and it will be applied to this code word. Now, at this code word it will be applied to the checker, where we have to check that whether the error has occurred or not, and in this case you do not have to remove it, you do not have to delete it, you have to correct that particular error. Firstly, it will be checked and then you have to correct that particular error and the corrected data will be transmitted to this data word at the receiver side. So, this is the error correction block diagram which consists of the transmitter and receiver, and the checker will be there which will check and it will going to correct that particular data which error that has occurred at the receiver side. So, this is the error correction part. Now, next we will see what is Hamming distance. So, there are Hamming distance which is been calculated between number of bits, like this is 3 bits data will be there, this is 3 bits of data and you have to perform the XOR operation. So, what is the truth table of XOR operation? When the number of bits are 2, let us say, then it will going to generate this form of data, means when the 2 bits are different then the output will be high, and when 2 bits are same then the output will be low. So, this is the truth table of the XOR gate. Now, next we will see how we have to calculate the Hamming distance. Now, let me take an example, let us say this is 101 and you have to perform the XOR operation on this. So, you can easily see that this will be is equals to 0, this will be 1 and this will be 0. So, only this bit have changed. So, you can say that this is having the Hamming distance that is equivalent to 1, means the output is changed at the output or at the second code. What is the Hamming distance? It will be only one bit has changed from 1 to 0, 0 to 1. So, this is how you have to calculate the Hamming distance between the two codes. Next is the linear block codes. So, I have told you about linear block codes. Linear block codes is nothing, it is LBC codes or the block coding, which is n is equals to k plus r, and this is the theory related to the block coding, which is known as block code, or you can say it is the code word, where you have to add the data word plus the redundant bits. So, this is about the linear block coding. Next is the encoder and decoder for simple parity check code. If you want to check the parity of the bits, I have said that whenever you are going to transmit the data word plus the redundant bits, then only redundant bits will be checked, and these redundant bits are known as the parity bits only. So, this is the sender side, and here we are taking 4 bits of information, that is denoted by A0 to A3. This is LSB, least significant bit, and this is MSB. You can take any one, vice versa also. This is applied to the generator, where generator will going to add the parity bit depending on the combination of the data bits, and then it is been transmitted using this unreliable transmission. And at the receiver side, you can see that these bits will be received along with the parity bit, and then this is been checked at the receiver side. Now, this syndrome will going to calculate the error that has occurred, and it will going to remove that particular error, and it will going to be received at the receiver side. So, this is the encoder and decoder of the simple parity check. Now, this is all about the error detection and correction part 1. In the next lecture, we will going to study about different types of coding in detail. These are the references that you can follow. Thank you.